Good morning students, I am Benil, Assistant Professor, Department of Computer Science and Engineering, Pondicherry College of Engineering. In this video class, I am going to teach you Lex Tool, L-E-X, Lex Tool. Okay. So, what is the use of Lex Tool is, which is used to convert source program into tokens. Already we know the first phase of compiler is lexical analyzer phase. So, inside the lexical analyzer phase, you know source program into token, conversion of source program into token. So, what is source program? Ordinary C program. What is token? Is a piece of code which is used to identify the source program. Okay, that is a token. Okay, sequence of character, right. So, here Lex tool, I am going to teach you Lex tool. In order to make the lexical analyzer program is easiest way, we will use the Lex tool, right. So, we have a question like we cannot write that is in C program or Java program, this conversion of source program into token, shall we write that code into C program, Java program? Yes, we can write. The answer is yes, we can write, but there is a tool, whatever the source program you have given, this tool is used to convert into token. Clear? That I will teach you how it is converting into token. And before that, this Lex tool, we have a lab exercise also. Using Lex tool, you have to convert source program into token. So, this concept you should be thorough. Okay. So, how it is converting Lex program, source program into token using Lex tool? Clear? So, first one is we will write the source program and we want to save that source program by using lex.l format, lex.l file format. Sir, whether .l format is necessary if you raise a question? Yes, because the lexical analyzer, lexical compiler, it accepts only .l format. Clear? We cannot give the extension, give the file name as another file, but you can write lex.l, we can write your name.l, etc., but it should be .l format. Okay. So, that should be given to the Lex compiler, Lex compiler, clear? Lex compiler. So, this Lex file we have to give, or we have the input we have given to the Lex compiler. The output file is lex.yy.c. It means if you give a Lex program, the output file C file will be generated, that is lex.yy.c file will be generated. Okay. That is the duty of Lex compiler. Clear? And second one is C compiler. The same lex.yy.c file you have to given to the C compiler. And you remember this lex.yy.c we cannot modify, because this operation performed internally by using a Lex compiler. Clear? That operation should not be modified, and we cannot change the file name also. Automatically it will create lex.yy.c file. That was given to the C compiler, and a.out file will be generated. You know what is a.out? We may familiar in a.out format, because we will use the C compiler, C program, Java program, etc. in open source. If you write C program in open source code, open source operating system like Ubuntu or Linux, you may know what is a.out. This is the output stream will be generated, input stream or output stream will be generated in this a.out. Okay. So, here this is input stream will be generated in the a.out format. That means C compiler, it compiles that lex.yy.c and gives a.out. Okay. If you see a.out, this is the input stream, that means in this one we give input to a.out, we will get a sequence of tokens, clear? This is the use of, or this is the procedure to execute a Lex compiler. Clear? Once again I will tell you, we have to write the Lex program, only Lex program, not a C program, Lex program. It is entirely different than C program and Java program. Okay, this is Lex program. I will teach you how it is entirely different from C program and Java program. So first you have to write a Lex program and save that Lex program into .l format. You give to the Lex compiler, the output C file will be generated, lex.yy.c, and the lex.yy.c you have to compile with the C compiler. Output input stream will be generated, that is a.out. If you see a.out, there is a sequence of tokens will be generated. Okay, so this is the procedure to execute a Lex program. Clear? We have a Lex program in our lab exercise. So this procedure should be, you know this procedure. Clear? Right. So if I ask you to convert Lex program into, source program into tokens by using a Lex tool, you should remember this one. First we want to type that Lex program, and we have to save that in .l format, and you want to compile the Lex program using Lex compiler, and automatically if you see ls, if you type ls, you can see the directory. Inside that automatically lex.yy.c file will be generated. If that file not generated, you must understand that Lex program what you return, the syntax is wrong. Okay, if the Lex program is correct, it's compiled clearly, then automatically lex.yy.c file will be generated, and that file you have to give on to the C compiler. So C compiler is used to convert that C program, and it executes a C program. It gives the input stream, and that input stream, if you see a.out, if you see a.out, you will get a sequence of token. This is the procedure to run or execute a Lex program. Okay. So next one is syntax for Lex program. Syntax, we have a all the programming language we have a syntax, right? Similarly, Lex programming language, Lex tool, we have a syntax. First one is declaration. Declaration. Okay, so inside this declaration part, we can declare number, constant, variable, whatever we need to run a program, everything we should declare in a declaration part. Okay, so first one is declaration part, and then we start with the two deliminatory symbol. This is very important in a Lex program, two deliminatory symbol. You can ask, sir, if I give one deliminatory symbol, it won't execute. Okay, two deliminatory symbol is necessary, because the transition rule function start with the two delim symbol, deliminatory symbol, right? And now it is transition rule. Transition rule. Okay, and end with the two deliminatory symbol. Okay, and last one is auxiliary procedure. Auxiliary procedure. Auxiliary procedure. This is the syntax for Lex tool. Syntax for Lex tool. What is first one is declaration part, second one is transition rule part, third one is auxiliary procedure part. So declaration part, after declaration part, you start with the two delim symbol, and last the transition rule end with the two delim symbol. Okay, right? This is the syntax for Lex tool, and transition rule consists of pattern action. Pattern action. This is the format of transition rule. Pattern action. Okay, so I will teach you when I am explained with the example. Okay, so this is the example of Lex program. Examples of Lex program. I will tell you what I told you. Declaration part. First one is declaration part. See, this is the declaration part. I have declared less than symbol, less than operator, less than, equal to, not equal to, number, constant, variable, whatever we are going to use in a program, that should be declared. One small example I will tell you. If you give the input source program as a equal to b, so a is a variable, right? That should be declared. Equal to is an operator, that should be declared. B is a variable, that should be declared, right? So a equal to b, this is the source program. The output token is, it should tell a is a variable. A is a variable. So this is the token. A is a variable. And equal to, it should tell equal to is an operator. Equal to is an operator. B is a variable. Like that it should tell. That is the, this is source program, this is token. This is the aim of our program. Okay. Okay. First one is, I told you, it is declaration. Letter, deliminatory sim, delim, regular definition. This is regular definition. Declaration. Okay. It should be, letter should be capital A to capital Z, or small a to small z, etc. So, and symbol is /t, /n and plus, these are the declaration part. So, till this it is a declaration. Okay. And I told you transition rule, before that it starts with the 2 delim symbol. See, it starts with the 2 delim symbol and and end with the 2 delim symbol. So, till this it is a transition rule, clear? Transition rule. I told you transition rule in which format? Pattern, action, okay. See, if is a pattern and this is an action, right? Return if, that means the C program will perform the operation, that is auxiliary procedure, perform the operation, and it correlated the output should be given to if in this section, okay. Pattern, action, equal to is a relational operator, less than is a relational operator. Whatever the things you are going to write in a program, everything should be performed by the transition rule, pattern, action. Action, that is done by a auxiliary procedure, that is a C program, and it returned the value there, okay. So, this is the way, this is an example. See here I used less than, greater than, equal to, open brace. Even we can write a hash, I will say hash is a header file, right, hash, and that hash include even whatever the things you are going to write in a program, that should be a declaration part, and that action should be returned in a transition rule. And auxiliary procedure, last one is auxiliary procedure. This is ordinary C program, we will perform the action, okay. So, this is the way to execute a lexical analyzer and Lex compiler, okay. So, you have to study this, because in your lab, in our lab exercise also we have this program, okay. Next session I will teach you another one tool, that is Yak tool. Thank you.